And prior to opening the floor for question, I'd like to move to the presentation from CNSC staff as outlined in CMD 14H2 and 14H2.B. I understand that Mr. Rozankowski will make the presentation. Please proceed.
Thank you. Good morning, Mr. President and members of the Commission. My name is Greg Rzędkowski, and I'm the Director General of the Directorate of Power Reactor Regulation at the CNSC. With me today is Mr. Miguel Santini, Director of the Pickering Regulatory Program Division, who will present the CNSC staff's position on the release of the hold point. CNSC regulatory and technical staff are also present and available to answer any questions the Commission may have. CMD 14-H2 presents CNSC staff's assessments, conclusions, and recommendations pertaining to OPG's request for the removal of the hold point in the Pickering Power Reactor Operating License. Our presentation this morning summarizes this information, as well as provides additional information to address concerns raised in interveners' submissions. This presentation is based on our supplemental CMD 14-H2.B, which addresses OPG's adjustments to Pickering A large release frequency submitted in OPG supplemental CMD 14-H2.1A. I would like to begin by providing a brief outline of our presentation. As you can see, it includes background information to establish the regulatory context for today's hearing. This information is followed by a discussion of the matters presented today for the Commission's consideration, which include the conditions for the release of the hold point and other information of regulatory interest. The presentation will end with CNSC staff's conclusions and recommendations. The Pickering Power Reactor Operating License was renewed in August 2013 for a 5-year period. During the Part 1 relicensing hearing in February 2013, CNSC staff recommended a hold point be included in the license to give appropriate regulatory oversight of the outstanding submissions from OPG relating to the fitness for service of fuel channels beyond 210,000 equivalent full power hours. The hold point required that OPG submit, among other things, improved or new tools for demonstrating continued fuel channel fitness for service. Furthermore, the hold point required that these tools be found acceptable by CNSC staff prior to the first Pickering B unit reaching 210,000 equivalent full power hours. Details relating the expected submissions from OPG are in the License Condition Handbook. Through the record of proceedings, the Commission directed OPG to submit additional information prior to seeking removal of the hold point. This additional direction from the Commission was also captured in the License Condition Handbook to allow CNSC staff to track compliance. This slide lists the matters for consideration before you today. First, demonstration of fuel channel fitness for service beyond 210,000 effective full powers. Second, completion of the probabilistic safety assessment, namely the revised Pickering A PSA, the updated Pickering A and B PSA to include Fukushima Action Plan enhancements, and the development of a site PSA methodology. Third, enhancements to protect containment. We will also provide an update on off-site emergency preparedness following Commission requests documented in the record of proceedings. This will include the status of the development of regulatory document entitled nuclear emergency preparedness and response. I would like now to pass the presentation over to Mr. Santini.
Thanks, Greg. The first condition of the release of the hull point is the full channel fitness for service. CNSC staff have a clear and robust regulatory framework in place to ensure continued safe operation of reactors. As required by License Condition 7.1, the licensees must implement and maintain programs to ensure fitness for service of the pressure tubes. These programs include engineering capabilities to assess the structural integrity of the pressure tubes and in situ inspection. The CSA standard N285.4 and N285.8 set the rules to follow for assessing the conditions of the pressure tubes. The regulatory document RD 334 on aging management for nuclear power plants sets out the requirements for managing the aging of structures, systems, and components at the nuclear power plant. I would also like to add here that the safety assessment of an unlikely event of a pressure tube rupture to demonstrate that the reactor can be shut down, depressurized, and cooled in a timely manner to avoid fuel failures and releases of radioactivity from the plant is performed in accordance with License Condition 5.1. CNSC staff carry out regular oversight of the fitness for service of all components important to safety. CNSC staff specifically review and inspect the following outputs from the licensee's programs: the life cycle management plans, inspection results, and control room procedures and protocols. In addition, the many years of operating experience and research, routine inspections on all operating units, and the in-service performance give CNSC staff the necessary confidence on the fitness for service of the pressure tubes. The integrity of the pressure tubes is continuously monitored during normal operations by the control room staff. The monitor includes both the leak before break detection of pressure tubes and the break detection in the heat transport system. Leak before break ensures that the reactor can be shut down in a timely manner if a crack develops in a pressure tube, while fracture protection ensures that hydrides in the pressure tubes have not increased to a level which can render the pressure tubes too brittle to prevent cracks. In the unlikely event of a leak from a pressure tube, the consequential leak will be detected in time to shut down the reactor and cool and depressurize the primary heat transport system before the pressure tube rupture. At Pickering, between 2 to 3 units pressure tubes are inspected every year to scrape samples, and scrape samples are taken to monitor the impact of the degradation mechanisms in accordance to the periodic in-service inspections. It is important to note that ongoing research efforts are directed at refining engineering methodologies and models to conservatively assess the fitness for service of the pressure tubes. Based on empirical evidence provided by OPEX and Research and Development, the Fuel Channel Life Management Project looked into the degradation mechanisms of the pressure tube, especially into the main contributor, which is the hydrogen pickup and its effect on the fracture toughness. As you may recall from the March 27 meeting presentation, we stated that the material toughness decreased at low temperatures when the reactor was heating up or cooling down. The operating envelope has been designed so that the increases of temperatures are made at the lowest possible pressure to reduce the stress on the material. That way, the reactor is always operated at states such as the safety margins to rupture are acceptable. The graph on the slide specifically shows the curves for Unit 5 to 8 at Pickering when the hydrogen concentration reaches 80 ppm. The projected to achieve beyond the 247,000 effective full power hours. In this way, adequate safety margin will always be maintained, since OPG has conducted experiments where the pressure tube have been successfully tested up to 120 ppm of hydrogen. On this basis, and given the present level of knowledge and operating experience, staff has confidence that the predictive models could project life of pressure tubes until 247 effective full power hours. 247,000 effective full power hours. This summarizes our conclusions for this condition for the removal of the hold point. OPG has met all hold point release criteria which relate to continued operation beyond 210,000 effective full power hours. The knowledge gained after many years of operation and enhanced surveillance of monitoring of the in-service pressure tube gives staff confidence to support the current projection for pressure tube fitness for service until 247,000 effective full power hours. This projection is based on current model hydrogen intake estimates, which is the most limiting parameters for fitness for service. It is to be noted that the models are confirmed or adjusted if necessary after each planned outage and factoring in all of the test results of the operating pressure tubes. That allows to revalidate the models on a continuous basis to prove the fitness for service of the pressure tube. This projected fitness for service limit brings the projected operability of the pressure tubes beyond the current power reactor operating license expiry date of September 2018 for all Pickering B operating units. As you may recall, the Pickering A was retubed in the 80s and have been in operation much shorter time than the Pickering B units. The second condition of the removal of the hold point relates to the development of the PSA. CNSC staff has a clear and robust safety analysis framework in place which consists of deterministic and probabilistic approaches which are complementary in nature. It has to be understood, however, that the current approach is largely deterministic to clearly demonstrate that the dose acceptance criteria are met. The CNSC is one of the few international regulators that require full-scope single-unit Level 1 PSA, which identifies the sequences of events leading to core damage, and Level 2 PSA, which identifies the sequences leading to large releases to the environment. In addition, as per S294, licensees are required to define their safety goals as part of the methodologies. Currently, the PSAs must be updated on a periodic basis. The dates for the PSA updates are specified in the License Condition Handbook. The purpose of the revision is to apply latest models or reflect improvements to the reactor design. The deterministic analysis used in the safety reports also undergoes the same type of periodic updates. This slide describes CNSC staff review process to ensure compliance with S294. The review and acceptance of licensees' PSA methodology is the first step in the review. This element includes the acceptability of the licensees' proposed probabilistic safety goals. The methodology is reviewed against the IAEA guides listed in S294. This review is carried out early in the process and before the models are fully implemented by the licensee. Once the methodology has been accepted, the PSA results are reviewed in two phases. The first phase is a high-level review to confirm whether the accepted methodology was implemented. At the end of this stage, staff can conclude if the PSA is complying with the S294. Further, more detailed review ensues in a second phase, where staff samples and verifies the models used for the dominant contributors. This second phase usually only results in minor adjustments, if any. But before we continue presenting the results of the PSA, we need to reiterate the significance of the PSAs in the context of the safety case for a facility. The CNSC staff, as any other nuclear regulator in the world, based the safety case on deterministic requirements and analysis using the defense in depth principle to minimize risks. Starting from the basis that the plant is deemed to be safe based on deterministic principles and analysis, the PSA complements this approach, offering insights in the relative safety importance of event initiators, response of systems, and of operating procedures. The PSA may identify potential vulnerabilities, and it can be used to prioritize the safety issues to focus primarily on items that result in large safety gains. For the operating reactor, PSA contributes to assessment of the overall safety performance and highlights points for which the design or operating changes can be deemed necessary. As per S294, CNSC staff accepted OPG's methodology for the PSA modeling and the safety goals to be met. These are aligned with the current international practices and are now part of the licensing basis. The Pickering licensing basis calls for the calculation of the core damage and large release frequencies for each of the hazard groups shown on the slide for a single unit and compare each of them separately with the accepted safety goals. Several interventions claim that the PSA results show that the Pickering does not meet safety goals for large release frequency or core damage frequency. CNSC staff had added the frequencies for illustration purposes only, since the simple summation has no regulatory value given the status of development of the external event models. Furthermore, there is no currently international consensus on how to aggregate the internal event frequencies with the external event frequencies. The reason for that is the simple summation of internal events and external events provide biased results due to the large uncertainties associated with external events PSA. Return to the specifics of the whole point condition number 2. OPG submitted a complete PSA for Pickering A prior to the inclusion of the Fukushima enhancements. Staff confirmed that the PSA complies with the accepted methodology and hence is complying with its S294. The core damage frequency and large release frequency meet the safety goal limits per reactor year of 1 in 10,000 years and 1 in 100,000 years respectively for each one of the hazard groups. Similarly, also for condition number 2, OPG submitted the complete PSA for Pickering A and B with the inclusion of the Fukushima enhancements. Staff confirmed that the PSA complies with the accepted methodology and hence is compliance with S294. The core damage frequency and large release frequency meet the safety goal limits per reactor year of 1 in 10,000 years and 1 in 100,000 years for each one of the hazard groups. Due to the lack of appropriate models, OPG has not yet incorporated in the PSA all of the Fukushima enhancements, for example, the Severe Accident Management Guidelines, SAMG. Now we will focus for a few minutes on the aggregation of hazard group frequencies. As stated before, there is no consensus on how and if to aggregate internal event frequencies with the external event frequencies. There is a clear interest for interveners to compare the aggregate numbers with the safety goal, as if this was the only measure of safety of the plant that matters. The table in the slide shows the simple summation of frequencies at power and shutdown states of all hazard groups contributions with the inclusion of the main Fukushima updates. As you can see, the large relief frequency aggregated for Pickering A is the only number greater than 1 to 10 to the minus 5. It is expected that more reductions to the frequencies will result when incorporating the SAMG models once developed. After the CNSC staff submitted the CMD for this hearing, OPG made some refinements to account for the use of emergency mitigating equipment related to Fukushima for the shutdown states. OPG reported these corrections on the supplemental CMD with a final aggregated large release frequency of 1.03. The emergency mitigating equipment was not credited in the first round as first approximation due to the low contribution of the hazard groups at shutdown state. Due to the fact that the progression of accidents leading to large releases following a containment failure is very slow, typically much greater than 12 hours. The operators have plenty of time to mobilize the emergency mitigation equipment, inject cooling water where it's required to address the progression of the accidents and to protect the containment. Due to this credit, the estimates of the hazard group's contributions in shutdown state have been reduced significantly. In other words, the credit of emergency mitigating equipment reduces the calculated large release frequency in shutdown state to values less than 110 to the minus 7, which for all purposes could be considered approximately 0. For the time at power, OPG used historical data for units 1 and 4. Conservatively, OPG assumed that the units are at power when they are not in guaranteed shutdown state. It is to note that many times the units are shut down but not in guaranteed shutdown state. Based on the data, the units are considered to be at power 78% of the time. The shift manager could initiate the mobilization of the EME when the criteria are met, driven by emergency operating procedures, to maintain the service heat sink at shutdown. At this time, we are not yet in SAMG space yet. These refinements, however, were sufficient to further reduce the large release frequency as described in the technical report submitted on Friday by OPG. The report was received and reviewed by staff, and after a high-level review, staff concluded that OPG refinement is acceptable. They are judged to be technically sound and properly supported. Staff is planning to follow with a more detailed review as it does for any PSA correction or adjustments submitted by the licensees. Again, it is expected that more reductions to these frequencies will result when incorporating the SAMG models once developed. For multi-unit PSA, there is the intent to reach consensus among international community practitioners. The calculations require first to develop the consensus to aggregate the contributions for single unit. As mentioned before, the simple summation method was described in the previous slide and is considered biased, followed by the addition of contributions of all units for all operating states. As described in at the March 27 meeting, OPG has initiated the work and it has submitted a concept methodology and the estimated implementation time. This was done through work with Canadian partners and international community experts. It is expected that the implementation of the new methodology for the Pickering site will be completed by 2017. CNSC staff is satisfied with OPG submissions to date and estimated implementation timeline. You might recall from the March 27th presentation at the Commission meeting, we mentioned that the current single-unit PSA models already include impacts from events in adjacent units. Hence, simply multiplying the result for a single unit times the number of units is wrong, because it leads to double and sometimes multiple counting of the same contributions. For the whole site, and in order to better reflect the reality, the CNSC staff performed a first-order approximation calculation to eliminate some of the multiple counting. We concluded that the whole site results are at least 60% lower than the simple multiplication by the number of units. This slide summarizes our conclusions for this condition for the renewal of the whole point. Staff confirmed that the PSA before and after Fukushima enhancements are compliant with S294 and that the accepted safety goals are met. The licensee must perform additional work to incorporate all of the Fukushima enhancements, such as SAMG, for which the methodology needs to be developed. Also, staff is satisfied with the progress made on proposed timelines for the multi-unit PSA by OPG. And why, you may wonder, why is this acceptable to staff, the proposed timeline for multi-unit sites? To answer this question, we need to reiterate how the PSA fits in the context of the safety case for the facility. We must start from the basis that the plant is deemed safe based on deterministic principles and analysis. The safety case is built from deterministic rules and proven engineering practices for the design to ensure defense in depth, those acceptance criteria for design basis events are met, and reliability of the system's important safety. The PSA complements this approach. For the operating reactor, as stated before, PSA contributes to highlight points for which design or operating changes may be necessary for continuous improvement. The PSA indicators, such as the core damage and large release frequencies, are used to show whether changes in configuration or procedures contribute in the right direction, i.e., produce a safety gain. As a third condition for the release of the whole point, the Commission requested information in relation to containment, venting, and protection. This very topic was one of the actions in the Fukushima Action Plan. The Pickering containment system, which includes the vacuum building, already had design features to minimize releases after an accident. Among other features, the system has a filter-aid discharge system. The system is designed to cope with design-basis accidents. The Fukushima event taught us to look into beyond design basis. The Fukushima Action Plan requested the licensee to look at different options in the event of severe accidents to enhance the protection of the integrity of the containment while minimizing the controlled or uncontrolled release of fission products. Given the relatively short time to end of life of the plant, the option had to be implementable in the shortest time possible. Also, the current features and limitations of the design needed to be taken into account. The slide lists the options chosen by OPG and accepted by the CNSC staff in response to the Fukushima action. Some of the features have already been implemented, and the remaining must be implemented as per approved plan before the end of 2015. In addition to the conditions of the release of the whole point, in the records of proceeding, the Commission directed OPG to develop and distribute emergency management information document to the public in the primary area before June 30th, 2014. You have seen the brochure that has been distributed to every household in the primary zone this week. Staff would like to highlight the extensive consultation process followed by OPG to maximize the benefit in terms of public preparedness to all people living in the primary zone. Staff would also like to provide an update to the Commission on the latest development of the off-site emergency preparedness front. The development of CNSC Reg Doc 2.10.1 entitled Nuclear Emergency Preparedness and Response was identified in the CNSC Fukushima Action Plan as well. It is aimed to enhance the emergency preparedness and response regulatory framework by incorporating lessons learned from Fukushima as well as international best practices. Reg Doc 2.10.1 focuses on the responsibilities and actions of the licensee and is well aligned with the new CSA N 1600 standard on emergency preparedness. The CNSC staff has completed the public consultation on the Reg Doc and comments have been dispositioned. Currently, CNSC staff are consulting with stakeholders, namely the off-site authorities, on additional requirements. The document is on a schedule to be presented to the Commission for approval in August 2014. We'd like to draw the Commission's attention to some of the new requirements staff would like to add to the current draft in light of the multiple public concerns. These additional proposed requirements are: firstly, licensees are to work in collaboration with the appropriate authority to ensure that KI pills are on hand, for example, pre-distributed in all residences, businesses, and institutions within the designated primary zone, which is 10 kilometers in Ontario. In addition, licensees are to ensure that stocking of additional KI pills for residents beyond the primary zone. Secondly, in response to the Commission's direction given at the Pickering hearing on public information for off-site nuclear emergency, this has been formalized into Reg Doc 2.10.1. It is which now requires licensee to undertake more active and regular public information on emergency preparedness and response. And lastly, licensees are to assist off-site authorities in their emergency planning by providing a planning basis that includes release and source term information. I would like now to turn the presentation over to Dr. Czenkowski.
Based on information assessed, CNSC staff are confident that OPG has met all the prerequisites imposed by the Commission for the release of the hold point. In addition, staff would like to point out that OPG is contributing to the improvement of the public awareness and preparedness for nuclear emergencies. OPG will complete this week, and in preparation for the Unified Response exercise, the distribution of information brochure requested by the Commission by the end of June. Further improvements of preparedness will be achieved through a more active participation by OPG in the distribution of the potassium iodine tablets to members of the public in the area. In closing, CNSC staff recommend that the Commission remove the hold point in the Pickering operating license to allow operation of the Pickering units beyond 210,000 effective full powers. In addition, staff recommend that the Commission direct OPG to collaborate with provincial authorities to ensure that a sufficient quantity of potassium iodine tablets is pre-distributed to all residents, institutions, and businesses in each sector of the designated 10 kilometers primary zone around Pickering and PP. This direction and the implementation timeline will be described in the License Condition Handbook, following directions from the Commission in the record of proceeding and reasons for decision for this hearing. Staff will continue to monitor the mandatory pressure tube inspections to ensure their appropriate fitness for service and the research associated to continuous improvement of the knowledge of degradation mechanism. Staff will also monitor progress in the development of the whole site PSA. As well, it will develop the matrix for safety goals in the context of the whole site. Staff will report the progress through the annual Staff Integrated Safety Assessment NPP report. This concludes our presentation. CNSC staff now are available to answer any questions the Commission may have. Thank you very much.